Hello and welcome to Merlins-Maker-Spaces. Let's make something today. Today's project is going to be one of a series in several different programming languages and frameworks. And for now, we're gonna make a simple apple catcher game in Python and Raylib, like the ones you often see in Scratch or MakeCode Arcade. And yeah, you may already know Python is one of the most popular programming languages due to its ease of use, clear syntax, and of course tons and tons of modules that can be used in conjunction with it. And Raylib is also a pretty cool game making library, which binds well with many common programming languages, and of course therefore encourages learning several languages at the same time, simply by porting it over to one another, right? And another cool thing is, of course, that it is both very useful for 2D projects as well as 3D. Anyways, without further ado, let's start it in easy peasy pace by building the game window we'll use as our canvas and drawing all the game objects, right? Before we start, this mini course assumes a basic understanding with Python. Like, for example, loop structures, classes, variables, lists, and all the like. So nothing too complicated, and we'll do it slowly anyways. So let's start with our project directory. Here in VS Code you can see the basic directory with the main.py file and two subdirectories, one for images in the assets folder and sounds. So for now we'll mostly focus on the main file as well as the images folder. Okay, let's start. First we've got to import the libraries. From Raylib, import everything. That's a little star, the asterisk. From PyRay, import... import star as well. So this gives us the basic functionality for drawing and playing sound. And also we need from os.path, import join. So this is going to help us loading the assets in the respective directories. And then we'll start building our game class. Just a sec. Okay. First the keyword class, then game, colon, and then we'll start with the constructor, the initializer function, also called dunder_init. Define __ init __ and self. Okay, for now we'll just add pass in here. That's just a placeholder so that we don't get any errors when we run the program in the early stages. Now dev update self, same thing, pass in here. That's going to be the update function for later on when we implement all the movement code of the objects later on. Now we got the draw function or method. Pass for now. All the drawing calls will be done inside that one too. And a run method, which we'll be using for the main loop. The main gain loop that is repeated, that is iterated upon. Down here we'll put an if statement. If name is equal to main. Then we want to create an instance of our game equals game parentheses, and then finally call game.run. So in simple terms, the statement says that this is the top level main file and only execute everything when this particular file is being run and not when starting another external file. Like if I would use in another instance a file with, for example, enemy classes, other functionalities, or for example the player file, the player data in an external file, and if I would run that, the entire program would execute. That could, under certain circumstances, cause errors. So that's not what I want. I want to start from the main file and only from the main file. Anyways, in this example, in this particular example, it's not that urgent that we use this, but I think it's just a good exercise to include it this way. Well, you know, practice makes perfect and all that stuff. Okay, let's add some attributes to our game class up here in the dev_init method. Remove the pass. And then we'll add the screen width and the screen height first. Self.screen width equal to, let's make it 1600. Self.screen height, let's make it 900. And then add a title for the app. Self.applecatcher. Self.title is equal to applecatcher. Okay. Of course, you may, if you are more creatively inclined, use whatever you like. Anyways, now we are going to initialize the window using the special Raylib method initWindow, which takes exactly 3 arguments. We'll add the screen width, self.screen width, self.screen height, and the title, self.title. And in theory that should be already enough to show us something. So if we run the program, we'll see a brief flash, and there was our window. But yeah, it kind of closed itself very quickly. In order to prevent that, we of course need the main game loop. How do we do that? So let's go down here into our run method. Well, we have the pass, we remove that, and then we'll type while not window should close parentheses then we do something. Then we do all our update and drawing stuff, so we can already add, although they're not yet finished yet, but we can already add self.update and self.draw. So you can see, while the window is not closed, it's gonna keep looping, right? It keeps executing the code we have down here. And if we, however, happen to hit the escape button or click the X, we're gonna break out of the loop and the program will end. And for a proper ending of this program, we have to close the window. And Raylib has a special command in here, just close window, so it properly deinitializes everything we've just set up on top of here. Okay, what next? Let's try it. Yeah, we're already seeing something. We got our title bar and we get, yeah, this blank white screen. Not exactly perfect yet, because if you try to exit out right now, if I press escape, nothing happens. And in here, yeah, the program simply crashes. That's not exactly what we want. So why is it happening? That's because we're not flipping our screen buffer, right? The place in it's like page flipping, like your scratchbook, right? You draw something on one side, then flip it over, show it to the observer. Then while you do that, you keep drawing the next drawing, the next frame, and then flip it over again, erasing the other picture you previously draw. Well, all this drawing stuff, rendering stuff, is not happening right now. So we have to go into our draw method. Let's go there. And use another statement from Raylib. Begin drawing and end drawing. So between those two function calls, all the page flipping and drawing takes place. And so if we try it now and run the program, yes, finally we get our stable black screen, and we can either press escape, I'll do it now, or exit out. And yes, that's our basic window. But I'm not pleased yet. There's one important thing we can do as well. Clear the window. So whatever we draw on that, of course we are not drawing anything right now, but we have a special command, clear background. So normally you would choose a color constant like this, black for example, and wait a second, clear background color, isn't it? Good, saved. Yes, nothing would change. But we can also add another color, for example purple, one of my favorites. And ta-da! It would erase the entire screen, whatever we've drawn in that particular frame, and replace it with a background color. So for example, we could also choose red. Yes. Or also RGBA values, so standing for R. Let's say, make a tuple in here, and then we add, let's take blue or something. 0 for R, 0 for G, 255 for blue, that is the maximum value, and let's make it slightly transparent for the alpha value. Let's make it 128. Ah, I forgot to save, sorry. Now. Yeah. What happens if we have, let's say 64 down here? Yeah, maybe slightly less pronounced blue. Okay. Anyways, just for fun, I'll keep it in here. Purple. Okay. But of course, that is not exactly the game background we want. We need a background image that we can put in there. So we are going to load it. Let's take it. Oh, wait. Let's make a drawing method to keep things clear. Let's call it draw background self and pass for now. First we are going to load the image. self.bg, let's call it bg texture. To load texture. and then we use our join method. We import it from os.path, makes it easier. So it's located in the assets folder. Next one is images. And now the file name. I called it bgforest-image.png. bgforest-image.png. And then here in our draw method, we can simply make a Raylib function call, draw texture, and it takes the texture name we have set up, self.bg.texture, and of course the position as x and y coordinates. So normally it's the top left corner where we'll put it, and the color tint, the last argument, means that we can basically put an overlay. We can simply change the appearance of the texture we loaded by applying a color to it, right? It's going to multiply it and therefore changing the entire changing the mood of the image. For example, you could add a red color to make the colors more warmer, or add bluish colors to cool it down, for example. But in this case, I just want the original colors, so I'll add the constant white. That is mostly what you will need if you just want the default color from the texture. And okay, let's run this thing. My bad. Of course, I have to go into the draw method and call it self.drawBackground. Here we go. And ta-da! We see something. But now, of course, compared to the rest of the screen, this is very little. That's because we simply pasted it in the top left corner, but we did not resize or scale the image that we used. It's only a few hundred pixels in width and a few hundred pixels across. And our entire image and our screen canvas is 1600 by 900. So how do we do it? Well, the simplest way is, of course, just getting the attribute bg from the bg texture dot width, and then we simply set it to our screen width. And self.bg texture dot height is equal to self.screen height. And ta-da! That should do it. Yes, that's great and all, and I think in our case that would work very well. But there's probably a more refined way by doing this, especially when you want to add more transformations or filters or other stuff to that image. In that case, we would have to get this texture, of course. Yeah, let's comment that out first. Okay, let's remove it for the time being, because then we would have to load it into the CPU. Normally when we load the texture, it goes directly into the GPU, and it will take almost no time just to put it into the screen buffer. But in this particular case, if we want to add some transformations, then we'll have to turn it into an image first. Okay, so let's call it temp img load image from texture. That's our BG texture up there. And then we could call resize, no, image resize it is. Image resize. And then because it's a pixel image, right, with discrete little squares, we would probably choose next neighbor, NN, as the resize algorithm, right? Nearest neighbor scaling algorithm. If we would choose, for example, the ordinary bicubic scaling algorithm, there's a chance that it might get blurry or something. So in case of pixel images, pixel art, whatever if you make those things or download them somewhere, then you would rather prefer nearest neighbor to scale it. So let's put Temp.mg in here. And we also have to define the new height and the new width of the image. So we got that in here. We want our self.screen width and our self.screen height. Sorry. There we go. So that does it. It doesn't return anything. It does it basically in the background, in the memory. Now we need our BG texture. Let's make it an attribute again. Self.bg texture resized, we call it. Equals load texture from image. Temp.mg. So that should do it. And we just plug it into our drawing function. Self.bg texture resized. Good. Let's run it. And yeah, of course we cannot see any difference. It's basically the same. So it may not, the effect may not be as dramatic in this case. It's a pixel image after all. Anyways, those are two different ways doing it. One more thing. It may not be visible right now because we are not moving anything, but I think in game dev it might be good practice to cap the FPS. Otherwise our game loop will run as fast as our machine, or as slow as our machine, depending on what kind of horsepower you have in your computer. We'll also talk about delta timing later on when we move things around, but for now, let's make another attribute, self.fpscap. And we'll set that to 60. I think that is one of the most common frame rates we find. And then set target FPS to the self.fpscap we defined before. We can run it and look and see if everything works perfectly. And it actually does. No difference right now. Well, and so far that concludes the creation of our basic window. In the next part we'll cover the topic of creating the game objects like the player, moving them around, screen constraint, and many other things related. Okay, so I hope you enjoyed this little lesson, and yeah, see you in the next one. Have a good day, and like, comment, subscribe. I'm always happy learning something new. So see you around. Bye bye.